So in this video, I'm going to discuss the minimum number of operations to make all array elements equal to 1, which occur in today's LEETCODE 342 weekly challenge. So this is the last problem, that is D. So the problem is, like, if you have any difficulty in understanding or like coding the problem, then you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem is very simple. It is stated that you are given an array and you can do what? You can remove one element and replace it with the GCD of the element of that element with any of its neighboring element. Okay, like if I want to replace 6, I can replace this with either the GCD of 6 and 3 or the GCD of 6 and 2. Okay, so this is what it states. If you want to replace 2, you can replace it with either GCD of 2 and 6 or nothing, right? Because there is nothing over here. So this is what what basically the question states, and you have to find out the minimum number of operations in which you can make all the elements as 1. Okay, over here, if it is not possible to make so, you can return -1. Okay, so that is, in this case, it is not possible. So now the approach would be like, the problem is very nice and the approach is like, there is no naive approach for this problem. The basic approach is the most efficient approach because it has been given that the value of n, that is the length of the array, is not as high. Okay, it is not as high, so you can use any method. There won't be any TLE. So what is the method? This is also a method of a sub array. Okay, so what you have to do is you have to find the smallest sub array who has a GCD of 1. Okay, so let's say for 2634. So what are the possible sub arrays? One is 2, 2, 6, 2, 6, 3, 2, 6, 3, 4, 6, 6, 3, 4, and 6, 3, right? 3, 3, 4, and 4. So what is the GCD of this? 2. Of this, 2. Of this, it is 1, right? Of this, it is also 1. If this is 1, then this will be also 1. For this, it is 6. For this, 6 and 3 has a GCD of 3. And 3 and 4 has a GCD of 1, right? So this is 1. For this, 6 and 3 has a GCD of 3. 4 is 4, 3 is 3, and 3, 4 is 1. So what is the minimum length? Okay, what is the minimum length of the subarray that has GCD as 1? See, this has GCD as 1, this has GCD as 1, this has GCD as 1, this also has GCD as 1. What is the length of this? 3. What is the length of this? 4. So we don't need to consider this. What is the length of this? 3. So we don't need to consider this. What is the length of this? 2. So obviously we don't need to consider this. So what is the smallest one? Length of 2, right? 2. So once we get this, you can check all the elements before this 3 and all the elements after this 4. If any element before 3 or after 4 is equal to 1, remember one thing, we don't need to modify that. Okay, so let's say you have count of 1. Okay, let's say count of 1. So count of 1 is the number of ones which are in the left of 3 and right of 4. Okay, so in this case, coincidentally, there is no ones, right? So the count of 1 remains 0 for this case. Okay, like for this 2634 case. Okay, for this case. But there may be cases where the count of 1 won't be 0, it will be greater than 0. So once you are done with this, so remember one thing, if I am going to operate these two elements, so I can make either of them as 1. So let's say I am going to make this as 1. Now I can make this also 1 because this is 1. So 3, 1, GCD is 1. So that is 2 operations we have performed. Then this also 1. Now we have performed 3 operations. Now this has 1. So we have performed 4 operations. So see, what is the answer? The answer is 4. For this, it is not possible to get a GCD of 1 in any subarray. So we return -1. Like, you can check this. I'm not going to explain that why it is not possible. You can find out all the possible subarrays of this and check the GCD. It will never be 1. So this is 4, right? So what is the basic approach? The basic approach is you have to make any one element as 1 by making this, by getting this thing. Okay, and once you have made that 1 is like, it's, you know, like the COVID thing, it spreads. So this 1 spreads. Okay, the 1 spreads throughout the array. So only that element is going to be 1, the rest of the elements are not 1. So how many times do we need to perform the operation to make that as all the rest elements as 1? N minus 1, because that one is the element, that one is the subarray of this, which becomes 1, and minus count of 1, right? So we need n minus 1 minus count of 1 number of operations to make the subarray, and all, not the subarray, the all the elements towards the left and right as 1. And how many operations do we need to make the subarray as 1? It is obviously, you have to, like, this is, let's say the minimum length was minimum length, okay, so the answer would be minimum length plus n minus 1 minus count of 1. So let me explain this this problem with 2634, this thing. So 2634, so what is minimum length? Minimum length is 2, right? 2 plus what is n? 1 2 3 4, 4 minus 1 minus count of 1. What is count of 1 over here? It is, fortunately it is 0, right? So 2 plus 4 minus 1, right, becomes 4 5 6 5 1 second. Okay, I meant minus 2. Okay, this will be minus 2, sorry, my mistake, it will be minus 2. So this will be minus 2 and that becomes 4. Okay, so this is how this works. Okay, this is the formula. So how the formula comes, minimum length, okay, like I'll explain it. What is minimum length? It is the length of the minimum subarray which has a GCD of 1. So if we perform minimum length minus 1 operations, okay, minimum length minus 1 operation, so we can make this any one element of that subarray as 1, right? And we have to check all the elements remaining, that is n minus 1, right? We are going to make one element as 1. So how many elements are remaining? Initially there were n elements, now remaining are n minus 1 elements, right? And you can remove all the elements which are already 1, that is count of 1. So that is minus count of 1. So this thing, when added together, it becomes minimum length plus n minus 2 minus count of 1. So this is how this thing works. Okay, so I hope this is clear. Like, this is, if you can remember this form, if you can apply this formula, I think this works. So that's it. Thank you.